Well, hi, good morning. Thank you so much for joining me and my cat Bert here for another day on the another day dealing with a cat. He just walked over my keyboard, which is, you can see him on the keyboard there. But I switched it off, so it doesn't matter. But before I switched it off, he walked over it. I looked up at the screen, and the screen said, "Input language change notice." What? I almost panicked. Well, you're changing the language of my computer. I won't be able to talk to him. But anyway, nothing happened. I was able to cancel away. Okay. So, with my excited cat here. So, once again, another intermittent problem is plaguing this radio. The intermittency can be activated, if you like, by moving these guys around a little bit. Any one of these seems to be sensitive to the problem. When the problem's in place, there's a hum, and when the problem is clear, there's no hum. That's how I recognize it. So here he goes. He's going for the microphones again. Hey, listen. Look at how big this cat has got. I mean, it was a little kitten when I started this. It wasn't a big problem. Now it's a big problem. Yeah, just he needs something. He needs something to play with. Where's your brother? He's not in here. That's good. Come on, let's go find something for you to play with, because no, so yeah, this is the camera here. Okay, this is the camera. He pushed it over just before I turned it on. He pushed it right over. Oh my gosh. Who needs a radio when you got one of these guys? And I got two of them. I got three of them. But one doesn't count because she's old. Okay, this is crazy. This is crazy here. Okay, now I can start, I think. I've got my door closed, the cat's outside, he's playing with his brother. Gonna leave me alone. Okay, so how do we approach this? So I think I've done all I can do from just moving these things. I don't think anymore we're going to learn anything more from that. Hey, here's something interesting. I had this on the floor here. So this is a broken down power transistor, which you commonly see, except you usually see it on this side. But I ripped the top off, and you can look inside. This is what's inside those guys. That little chip-like thing is the transistor, and the rest of it is just housing. Probably for cooling. Not much inside, eh? Okay. Now, I think what I'm going to do is I'm going to tip the radio up, and we're going to try to make the problem appear, if it doesn't appear on its own right away. And that's right, and the problem with tipping this radio up is the cord sticks out the end. I have to put it up on blocks. We're going to, for now, unplug this. Gap here. I got to fill this with a piece of wood. I think I have one. It's just perfect for it. What's this? This looks too thick. Maybe that's close enough. Okay, up you go. Steady at all. I've had this up before and it was pretty steady. What did I do before? Too much weight hanging out here. Oh, it's got it pretty steady now. Okay. Now the area of interest here would be where those cans are. So again, we're looking right in at the area I worked on, and this piece of paper, which we want to take a look and see, is the paper doing the trick without moving it? So I'm really suspicious this is the problem right here. Take a close look at it. We'll see if we can just see something without touching anything first. And of course the radio's not on. It's not going to be on during this deal. Now, I've got to freeze the focus on this camera. Just take me a moment here. Need a lot more light. Now, a piece of paper here. Yeah, you can see clearly it is blocking the contact between the, let me pull it out here. There's no contact near there. Oh, yeah. From this angle you can't really see. I'm going to take a look with my eyes here because I can't tell from the camera shot. So one of the things, you know, when you're working on a radio and you've got it tipped up on its side the way this one is, you might do some work on it, and then when you lay it down, some of the parts will move a little bit because gravity's pulling them in a slightly different direction. Is that possible here? I can't believe that. I know I can't believe that's what's happening. I don't think this is the problem. Well, we're going to eliminate it. I'm going to cut away the original capacitor post, which is underneath this one now that I've put in. Can you get at it? One of the reasons why I haven't done this already. I did do it. It is cut. Oh, you know what? It's cut. And I left most of it on here. So I think we're going to remake this connection here. Just pull this big lug of junk out of here. I'm looking to see if there's a cold solder joint in here. I don't think so. Well, cutting that is not going to be easy. Just want to get the bulk of this metal out of here because it's doing nothing. Wow. That's going to come out of there like a bullet. No, it didn't. Now, I've really roughed this up. Looking for anything that looks loose. Any connections around here. This is the area of the, oops, area of the trouble. That's a little ways away. Okay, so this was one here. Oh, I found it. I found it. This one's not soldered properly. I think I can even say why. It's not soldered properly. By me. Take a look at it here. Yeah, that's pretty bad. Why is it not soldered properly? See, I tried to solder it onto this part here, which would require a lot of heat to heat up, and I didn't give it enough time. So that's a classic solder error on my part. I'm pretty sure once that's soldered, the problem will be gone. Okay, let's do that. So about a month ago or so, I put a video on YouTube that went viral, and it was me whining and complaining. You may have seen it, whining and complaining about what Mr. Trump was doing at that time. And since then, I've only done a couple more videos, and I don't feel inclined to do many more. And I'll tell you why. Because I don't feel as upset. And that's weird. Why do I not feel as upset? I mean, things are getting even weirder in the States all the time. It's because the Canadian leadership, especially the Prime Minister, has said things which has, I think, settled us all down in Canada and caused us to focus on what we need to do next. And I mean, it's not difficult. I mean, it's quite clear what we have to do, and we're doing it. And the result of this feeling of, and I know this how it works in people, when you feel you have no control over your future, you feel anxiety. That's what anxiety comes from, not having control. When you feel you have control, even if you don't actually, but if you feel like you have control, then you don't have all those negative feelings, and you don't feel paralyzed. Now, I don't think Canadians feel paralyzed. I mean, there are people losing their jobs here because things are happening. Unfortunate things are happening, and it's, you know, there's lots of stuff to be concerned about. But that panic that I felt at the start, you know, when somebody pulling the rug out from under you entirely, is gone. And I feel like a new rug's been put under me, and it may even be a better rug. We don't know yet. So that's what's happening to, and that's why you haven't seen me put up a series of whiny videos, because you know, I'm not inclined to do that, frankly. I'm not much of a whiner, and don't feel like it. Don't feel like a whining. Feel like getting on with it. It's amazing. Maybe it's just me. I don't know. Okay, what are we doing? Waiting for the soldering iron to heat up. It's long heated up. Now, when I make a solder joint like this, afterwards I usually inspect them. I have a little magnifier, I get up close, and I usually inspect them. And if I'm making one to something like this, where there's bulk metal involved, I'm well aware that it may take longer to heat things up, or you may not even be able to heat things up enough, because the heat just disappears. Like this thing is, you know, pretty large piece of metal here. And my little soldering iron may not be up to it. I think it is. That looks pretty good from my eye here. Let's take a look with the camera. I hear my coffee maker telling me it's ready. What did I just do? Hold still. Doesn't look very good, does it? It's like two kinds of solder sitting there. Looks like that would pop off. We're going to give it more heat, more time. More heat, more time. Oh. So I'm trying to get the soldering iron in a position where it can deliver heat the fastest, which I think is about there. I don't think it can get any faster than that. And there. And there's a component that's nicely soldered. If I can solder this to that component wire, that's fine too. But I think I've got it soldered to everything there. Looks good now. Does it look good? Let's take a look again. That looks a little better. I think so. I didn't realize wire just looped around once there. Yeah, it is. Oh, I haven't got much of a connection there at all. Okay, more solder. Keep pouring it on here. Okay, now I can see better what I'm doing. Didn't realize what I was soldering exactly. Well, I think that got it. I don't know. Let's take another look. That's got it. Still got a little bit of the old terminal hanging there, but that's okay. That's what I thought it was shorting to, but it was never shorting there. That's what the paper was blocking. Okay, I think we're good for a test here of the radio. We'll see if in fact I did manage to I'm sure I did. There's no doubt that that connection was bad right on the spot where I was wiggling it. Great. Okay, next thing we'll play the radio and make sure it's all working again. Okay, I think I'm going to try operating the radio up on its side like this before doing anything more. Speakers back in, no antenna connected. Here we go. Hopefully it's going to make some noise here. Maybe I've got to stick an antenna on it. Pretty quiet radio. No antenna at all. Let's put the antenna on. Aw, Bert, how'd you get the door open? Yesterday, my black cat, yesterday morning, before we got up, must have pushed the screen out on a window, on our upstairs window, pushed the screen out enough that it could get through the crack in the screen and get out onto the window ledge, and then the screen snapped closed behind it, and the cat was trapped on the window ledge. Now, how long it was on the window ledge, I don't know. In the morning, I got up, looking around for my cats, and I couldn't find the black one. Where's the black one? It must have been left outside all night. Oh no. But then for some reason I decided I would go ahead. He's doing the microphone routine here. I would go ahead and just look in the back room for her, and there she was. Come on. Oh my gosh, this has become just a game for the cat. Over here. Or this way. Over here. Look at this thing. Hey, what's this? Get your head out of there. Come on. Oh, now I've totally lost control of what I was talking about and everything. Yes, so the cat was trapped outside the window on the other side of the screen. It couldn't jump down because it's a story and a half high. The poor thing. I had to rescue her, which was tricky. How do you push the screen out? You ain't backing up there to see anymore. With a cat on the windowsill, pushing the cat off. Look, Bert, you've got to come down from there. Here, look, clear a space, and you got fancy feet. Use your fancy feet. Oh, that shelf is not stable. All the way down here. It's all clear. There, that's the spot. Make the jump. Go on, make the jump. You tell me do. Oh, and I gotta go back over here. That's my monitor up there that I use to keep track of what I'm recording. Yeah, now you're in the range. I got you. Oh, I got you. I got you. Yeah, I got you. There we go. You know what I'm going to do with you? I'm going to throw you out the door and close it. That's what I'm going to do. There you go, out the door. There, you can't push it open. Okay. I should say I'm sorry for all this cat nonsense, but I know a lot of you are getting quite a kick out of it, and frankly, I'm getting a kick out of it, so that's why it happens. Now, didn't I turn this on? I did turn this on. This is on. I forgot it was even on. And we were going to put the antenna on it, and then the cat showed up, and everything went haywire. It's very, very quiet without an antenna. Some radios are. Down. And, I'm sure I got the problem. I'm sure. Okay, all that I just wanted to check it while it was still up. I'm going to lay it down now, and we're going to try to align it. Didn't I try to align it a few times already and didn't get anywhere? Right. Okay, power off. Power off and video off for now. So I think what's going on here is rather than hook up your signal generator to A1 and A2, because one of the outputs of a typical signal generator is grounded, they're having you connect the output from the signal generator to either A1 or A2. They're specifying one of them. The ground side of your signal generator to the chassis here, and then they want you to put a chassis ground on down here or anywhere along this line. And I think what that does then, it first of all, this tiny capacitor here probably has too much reactivity at low frequencies, like AM frequencies, AM broadcast frequencies, that it's not providing the ground that it could. So you put a solid ground in, that's what it requests. Now you've got the signal going in here, going partly through here, and then it's finding a ground to be sort of drawn out the bottom here. This coil is designed for short wave. There's going to be less coil here, much more coil here. So yeah, I think that's what they're doing. They're just a sneaky way to apply a ground to suck the signal through this coil a bit. And the problem is you having a grounded instrument on both A1 and A2. That's my guess. That is my guess of why they want this. So we should see an effect. When I put a ground on down here to the chassis, we should see an increase in the signal going through the radio, because it'll boost the signal going through the coil here, which will transform over here and then head off to the grid. Okay, let's see if that's true. And the capacitor itself, this is really to provide a ground at short wave frequencies. That makes sense? That doesn't make sense. That doesn't make sense at all, because if you're feeding the short wave in here, the last thing you want to do is fire it through a capacitor to the chassis. You really want it to go back through here. And then this trimmer is also a very small capacitance. What would make it go back through there? If you hook up A3 to your antenna, and you got to get through this coil. The 1 meg resistor, what's that doing there? This is variable. That means it's tuning. And when is C1 adjusted? Is it part of the shortwave effect? Part of the shortwave thing? When does C1 get adjusted? When does C1 get adjusted? C. Hey, where's C1? Hmm. Can I do that one more time? C1 really exists? Oh, I was looking for this diagram and I couldn't remember where it was. Okay, great. That's something. That's just that. Well, C1 here. It's marked right here. Let me look on the radio. There's a C1 sitting right there. There is a capacitor sitting right here. But it's never called for. Come on. Let me look at this again. C1 never shows up in the list. Is it down here? Well, that's odd, isn't it? Huh. What are you supposed to do about that? Well, if you look at the schematic again here, I gotta flip it around. Whoops. Adjusting this, I would think that would have an impact on this coil. It would have an impact on this too, wouldn't it? I don't get it. I'm not sure what this is doing, but it's not listed in the chart. What are you supposed to do about that? Oh my gosh, look at all this stuff. I never read this. Precautionary lead dress. Keep tuning tube cable and lead from the left pilot light away from the grid gap. Okay. Lead. This is because there's a current flow feeding the light bulb, and you let the current flow get close to the grid gap. You're letting it get close to the grid, and it'll start getting amplified. Leads on spread band antenna RF coils should be kept as short as possible. Keep black lead away from L25. Let's see. Keep black lead. Cathode lug on J7. I should have read these before I did any work on it. The power cord and primary lead of the power transformer connected to the power switch should be twisted together. The power cord lead and the primary lead of the power transformer which connect to the power switch should be twisted together. Keep C13 away from the 6A control grid lead. Shield leads to Victrola jack. Shielded leads to Victrola jack must be dressed away from switch terminals and jack. Yikes. Well, none of this stuff, I haven't touched any of this stuff, so it doesn't really matter. Blue and black leads from antenna board to coils must be twisted. They are. Black lead and condenser, which connects to 6F6 plate, should be kept away from inverter, grid lead, and resistors which connect to it. It'd be great if the engineer took the time to explain on each one of these why. I mean, some of them are obvious, but some of these others aren't completely obvious. Shielded leads to Victrola jack must be dressed away from switch terminals and jack. Because, I mean, we can guess, but it'd be great if the engineer had come out and said what exactly this achieves. But he didn't. But most of these are not going to be a concern. C13 away from the 6A. Well, we'll see. You know, there was weird behavior in this radio where it at one point when I tuned to a certain spot, it went into motorboating, which might relate. You know, a long shot might relate to one of these things I may have booped up. We won't worry about it for now. Okay, what am I doing? I can't even remember what I was doing. I was examining the situation, getting ready to do an experiment on this to determine what's going on. And the bottom line is I can still experiment with it, but as for understanding what's going on, I'm not exactly sure. Well, I'll figure out what's better. Okay. This capacitor is missing completely, so we'll start with that. What happens if you put the capacitor in while you're feeding in a signal the way that they want it fed in, just into one leg here, Okay, I got the picture. I got the picture. Actually, a little more to the picture. If you follow their instructions, then the signal generator signal will energize this coil and this coil the whole time. If you were to hook it up just between A1, A2, you'd only energize this. And then in order to energize this guy, they've chosen to do it backwards from how it would normally go. Okay, good enough, good enough, good enough. Okay, with the radio off, practicing. So this capacitor or this one, I'll use this one here, both of which tested as if there's something terribly wrong with them on my tester, which didn't make any sense. Then we'll do this. Yep, and so that would establish. It's kind of sloppy, but even getting this momentarily on, off, I can do it like that. Good, that's going to work. On. We'll be able to find out what happens when you do or do not have this capacitor in place when the signal is being fed in, excuse me, this way. Which is not quite normal. Okay, signal generator's going, radio's not. Radio on. You know, we're not going to use the signal generator. I've got it back on the antenna here. I'd rather do this with a regular real radio signal. My voice is getting rough again.
So it's super hard. O'Brien touched 101 in that game before Kirk's home run. He threw him a 101 and then only threw 98 to Kirk on his home run. Helsley obviously throws gas. Both those guys were used yesterday. We might not see a guy throw 97 today from the Cardinals because they are, their bullpen is a bit more jump bally. They don't miss a ton of bats. However, if you look at the type of bullpens that make the postseason run, if you look at the type of mix and match stuff managers do, how much earlier they'll go to the bullpen, how much.
I would say it's getting slightly stronger with the capacitor connected.
When you get to playoff style baseball, I know the Blues
Now
have
we'll
a
see
long
what
way to
happens
go.
when you actually
They're
put a
in a
short
long
in.
spot today. We can't assume that. But if you were starting to think about playoff style baseball, if you're starting to think about how they'll look on the weekend against the Phillies, how they look in a series against the Yankees or the Tigers, when they go to
It's definitely
LA,
louder.
the Dodgers later
You can
in
watch
the year,
this
things
meter
like that.
actually. You
The ability to handle
don't have to
10%
guess.
almost of all reliever pitchers being 97 plus. It's a pretty important skill to be able to turn the tides on. And Clase and Kirk are
Not quite as much.
We're pretty sure Bobashet can.
Okay, so I think my thinking about why they want us to hook up the radio like this for a signal for testing purposes, grounding this thing, I think I understand why. Okay, so I have the ground in. I have the signal generator connected up the way it's suggested. And we're ready to go. The signal generator is running at 600. So let's switch over to that. So I think we were just listening to 590, right next to 600. I didn't tune the radio, did I? Did I tune the radio? We need to take a look at this. Okay, let's look through that camera, see what we see now. Ooh, way off 30. Now, something has happened. I bumped the pointer. That's probably what's happened. So we will reset the pointer. So I do that by tuning the radio to, where'd the knob go? Zero. Whoa, it's not off. You can see the zero is right on the left edge of the pointer. It was 30, wasn't it just 30? Let me look myself. Oh, I've got it on a piece of paper here. The proper angle for this is 30 degrees. 30 degrees should be 600. So we're at 30 degrees now. and I'm going to vary the signal generator. Let me switch cameras here, so because we're going to leave the tuning fixed now. Just shuffle it over here for a second. So I'm going to tune the radio back and forth, or the signal generator back and forth, and watch the pointer down, going the other way, up, 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 up. So it's off frequency for sure. So I think this is exactly where it was last time, and then I got involved in the stuff. Okay, so the adjustment we're doing now at 600. I get it wrong here. 600. The adjustment is the, of course, it's this guy. Second one in. 1, 2. Down amongst all these wires. Let me put the camera back in a sec here. There. There we go. How's that meter still reading? I just took the ground off. How's that working? It's finding its ground through this and through the power system. This is a 2-prong device. Hey, what's going on here? Oh, mysterious. Okay. Just write it in the book of stuff that didn't make sense. That's all. I got a thick book full of stuff throughout my life that hasn't made sense. I'm sure you do too. I'll tell you one I've learned. When you see smart people doing stuff, and you wonder, why are they doing that? Like, why would they do that? That doesn't make sense. I think they're doing the wrong thing. Smart people doing something that looks wrong probably means you don't have all the information they have. Okay, so we're ready now. 600 on the signal generator, and this guy's dialed up to 30. We're ready. We'll just turn this until he's maxed out. That would be maxed out. Can we leave that there? We can leave that there. Now we'll go to the 1500. We're just going to have to go back and forth, I think. Which brings up another topic, which I'm not anxious to talk about, which is the string on this radio. Hard working string. Okay. So 1500 was 151, wasn't it? 151. I think I'm right there. That would be 151 right there. Okay, now is it 1500 or what? Close. Turn the volume up here. Okay, still hear it. Now I want to adjust this this crazy plunger style capacitor here. That's really, really low. When the radio is receiving a low signal and you can hear the background noise, that means the front end has cranked up its sensitivity. The volume is turned up basically on the radio automatically. And that's why you can hear me touching stuff. You couldn't hear that before. Let's see if I'm full of crap again. When I get this corrected, which way are you going? Going that way. No, that got weaker. This isn't moving at all. What has happened here? I'm a little worried about that meter. changing, but I can hear it. Oh, here it goes. Well, I think this thing is pulled out all the way now, which is kind of the same situation we got into before. Okay, the primary thing is good tuning at the low end here. See, there's still more to go. Put it back on 30 properly. Now let me turn this volume down. Okay, we're back on 151, I think so. Now, the capacitor is all the way up and we can't get any more out of it. So I'm going to push the capacitor down. I'm going to do this wrong. I'm going to push the capacitor down a bit so it's not at its limit. Okay, just a little bit. And then I'm going to compensate with this and make this go max. I'm doing this at 1500, the wrong end. This is not the end I want to do that. Most of the stations that would be listened to are down at the lower end. So the lower end is a little more critical to get correct. So right now we've got this running pretty much 1500 at 1500. Let's go down and see what's happening at the other end now. Okay, so I would say that's 30. And go down here to 30 to 600. I don't think we're getting much closer. Not very smooth. That's the max on the meter, 603. That's not bad. You can only make this so accurate, and the dial can only be read so accurately when it's back in the cabinet, and the pointer is only so accurately tied to this scale on the back, and everything. There's just errors everywhere. So not to get too crazy about being precise. From a practical point of view, you want to be able to look at the dial on a radio, bring the pointer over to the proper spot on the dial, and then hunt briefly for the station. You can't expect it to be dead on, that's just a little too much. So if you have the radio set up so you bring it over to the right spot, but you can't hunt around until you find it's way down here, that's no good. You need it really close, but not dead on, I guess that's what I'm saying. From a practical point of view, for those who are going to spend hours tuning this radio, listening to shortwave, listening to broadcasts. Now, what have we done? What have we done? Have we done them all? C8 detector at 1500. We better check these other two, C3 and C8. And where is C1? Very odd. Okay, so we're going to go up to the other end, 1500, and check this. Why don't we check it right here? Why can't we check it right here? This oscillator one will change the radio's tuning position, but these ones won't. The antenna adjustment and the detector, they just make the radio stronger or weaker. They don't cause it to move the pointer around at all. Or very, very, very minimally. On cheaper radios, when you go to do these adjustments, the oscillator will move too, and it can be really, really crazy trying to adjust a radio that's like a cheaper radio than this. This one shouldn't do that. Too much talk, not enough doing. C8. Well, let's see. Where's C8? I think it's right there. C8. Detector. Okay, C8. Let's see if we get a little more out of the radio here. So to do this, we want to make sure the radio is tuned maximally to the signal. So I'm watching the meter over here. Hey man, watch the meter. Okay, and we can get any better than that. Okay. Going up. Ever so slightly. I've loosened it right off. So this is again another situation we can't quite get to a peak. We go down, no. So what's happening is you want the meter to go up and swing back as you go through, right? Up and swing back, and you just kind of finally get it like that. But what if you're turning the screw? This is the screw. You're turning the screw, and all that this does just keeps going up until you can't turn the screw anymore. It's still going up. It never got to the peak. Where is the peak? What is the peak? You don't know. And how come we can't get there? How come we can't get there? So I'm turning the trimmer open and reducing the amount of capacitance in the main, in this capacitor. One solution for that, one solution for that is to bend the plates on the capacitor, the outside plates, and bend them out. I'm not going to do that. I'm much more inclined to just leave it like this. Just go down. Meter go down. I'm cranking this thing down pretty tight. Never coming up. And then I loosen it off. And it just keeps going up. So we don't want to loose. We don't want to leave one of these things loose, and then you got a noisemaker. So you got to tighten it down a little bit. You know, I encounter this all the time, and I'm never too sure what to do. I suppose, you know, you could kind of re-establish the oscillator a little bit different and stuff like that. I don't think I want to experiment to that degree with this radio because it's working pretty good. Would that be the end of it then? That's the end of it. I think I finally made it to the end of the oh, wait a minute. Yeah, I've made it to the end. C39. C39. Yeah. Okay, I think we should play the radio on an antenna. We'll run through it up and down once, and then we'll, assuming all that's okay, we'll then start looking at doing shortwave stuff. It's still early. Okay. Let's, you know what? Coffee break would be a good idea. And then we'll switch gears to listening to the radio. Right. Got it. Okay, we're back on the antenna here, and we're going to do a couple experiments. Let's tune in something. Step this way, look that way, and keep an eye on this. Okay, we got a signal here. It's not 100% strong. Perfect. Let's take this ground off and see what happens. Yeah, weaker. You can see it got weaker here. But this antenna is not connected like a loop antenna should be connected. So we're going to connect it the way a loop antenna would be connected. It's not a loop antenna though. Ooh, that didn't work very well, did it? Let's reverse these. This time I didn't drain it out. I would expect a lot different response here than we're getting. Loop, ground, shortwave. Make any difference? If you're looking at the meter over there, it's straight up. Straight up again. Didn't make any difference. Surprised that this, well, this isn't a real loop antenna. Should we hook it up to a real loop antenna? Why not? I have one right here. So this is an unpowered antenna. Let me just back up the camera here so you can see more. This is an unpowered antenna, but it does have a tuning knob. This is quite appropriate for this kind of radio. We're going to take off the outdoor antenna. Now I am not. My shop is not in an ideal location. Red and black doesn't mean anything in a loop antenna. There is no polarity. As soon as I hook it up, it should have gone a little quiet. There's something going on with the loop antenna connections. Okay. Now this is also directional and tuning. So first we'll tune it. Not happy. It's not happy. Wow, there's something about this. Oh, I don't have that capacitor in. Does that make a difference? I wouldn't think so. Let's put the ground back on here. We'll do it without a capacitor. Okay. Don't seem to be tuning at all. Okay, what we'll do is we'll put this on the chassis ground. Ooh, that really killed it, didn't it? Turn the radio right up. Where do I have the radio tuned? I have it tuned at the low end. Oh, suddenly it starts working. What happened there? Bad wires. Okay, enough of that. So what we found out is it'll pick up a signal from this antenna, although there's some problems here with the plug or the wire or something like that. But in 2 cases, hooking up to the loop antenna inputs did not give the kind of response that I would have expected. And I don't understand that. Okay, but in any case, radio's working. I would say we're going to tune across the band now and just listen to this radio. Okay, up this back up.
A group of, I think it is 6 developers and their unions, and no one else is allowed to bid and participate in an infrastructure project in Toronto. The only city left in Ontario that still does that. Why does that happen? Well, because there's quid pro quo going on, is what I'm told from people I trust within City Hall.
Okay.
It's not actually bags of money going to city councilors. It's, oh, you need volunteers for your campaign. Hey, we've got some people who will help you out. I 100% believe that's what's going on. But that's 300.
We can start capacitor closed. So that'd be 530. And there is something there. Ooh, what was that? Oh, that's this. Oh my gosh, now my phone's ringing. Oh, I gotta run. Okay, confusion reigns. I got a phone call. It threw me all off. Right, we're going to tune the radio. Let's tune the radio. Here we go. So we'll go back to the start. So that's a community radio station from Toronto, I believe. I think this is Buffalo. Not sure. Lots of weak signals.
I saw from Eric Stephen on Blue Sky was so interesting and really revealing about Dustin May's health this was the first time in his career he's pitched in June in the majors, and he's about to be a free agent.
Okay, so I just tuned through a number of stations and finally arrived at what I believe is 590. So 530 to 590, and there's 3 or 4 stations in there. That's really, really good.
And he's just, it seems like so much bad luck for someone who needs that at the major league level. And so I think
this is 610. I think this is 590, strong, 610, not far from it. Excellent.
What's weird is trusting a system that prints trillions out of thin air.
I think this is 640, but it might be 680.
Or call 1-866-274-9570. Home real wealth in your retirement.
Real wealth. That's right, yeah. So this is 640. This radio is really working good. Now, I've said that, but it needs a good antenna to produce, do this kind of performance. But wow, let's keep going.
Is one of my favorite pop artists. You'll see 321 coming from this day in '88.
This is probably 710 from St. Catharines. I think that's a community radio from somewhere. Every one of these signals, by the way, is just transmitting to me along the ground. These are all ground wave signals during the day. There's no bouncing off the atmosphere. So these are all within a few hundred miles. Community radio. So I must have been wrong. So this is 860. This is Hamilton here. 820. 820. 780. I don't know what that is. I don't recognize it. French station. From here on, I'm not familiar with the stations because there aren't many to pick up during the day. But let's see what we can get. Any really weak ones might be American. Yeah, American. Okay, moving on. Oh, that's the volume control. Moving on, isn't that that's American, moving on. Wow, that's a Canadian statement these days, boy. There's another one. How about that tone control? It's doing nothing. Very strange. I think that's American by the accent. So American would mean it's from a state near me, like Michigan, New York. sounds American to me.
L'arrêt brusque.
Oh.
Donc, si je suis une personne qui passe d'être chez elle.
Oh, I am confused. So this is 860. What was that other French station? Montreal. There's a couple of Montreal stations I can pick up during the day. That's what that must have been. This is not from Montreal. This is from relatively local here, CBC. But I won't go back. It's picking up stations I don't normally hear on my own radios. That's why I told the owner I'm not giving this radio back. American again. By the accent, American. This could be Canadian advertising Disney World. The Wales Theatre. Lion King. Yeah, Merv. Okay, this is Canadian here. Maybe I misunderstood what they were saying. When they said Disney, maybe they didn't say Disney. Well, must be Canadian station there. So this radio gets top rankings here for its performance, for sure. Far, far away. Now there's a rock station up here, well, up towards the top. We've got a ways to go yet. Ooh. Huh, that's motorboating. So something about this particular tuned frequency, which the radio is self-receiving somehow. And that motorboating effect has to come from some kind of feedback thing. If you take 455 and double it, you get 910. And a lot of radios do weird things at 910. Maybe that's where we went by. I don't think so, Todd. I think we're well beyond 910. So this is a community radio again. I guess all radio is community radio, really, isn't it? So you're not saying much by saying that. I should say it's a local community radio that's low power, aimed at a small area. There are thousands of very low power stations in the United States. Here too, I guess. Generally, the ratio between Canada and the States is 1 to 10. So if we've got 1, they've got 10, that kind of thing. So if we got 1 radio station, they got 10. Roughly. I think there's something like 10,000 AM radio stations in the United States. I don't think there's 1,000 up here. We're getting close to the end of the run here. So I'm looking for one last rock and roll station. A local one from north of here. There isn't a lot north of here. Should be any time now. Come on. Not going to make it. Wow, didn't appear. I'm surprised at that. It's 1580 was what I was shooting for. Okay, so you can see the lower end of the band has got a lot more stations than the upper end of the band. At night, with a good antenna, a radio like this would pick up a station at almost every possible frequency. In some cases, the stations are so numerous and so low power, all you hear is this rush of noise from like 10, 20 different radio stations all on top of each other. And it's very faint, but you're still picking up the radio station. So I think this is a great receiver at this point. Depends on the antenna. So tomorrow we will approach the shortwave situation here and try to tune up the shortwave. Now, shortwave reception's been very poor the last while. Yesterday the what's the number? The sun something factor. The sun SF, I can't remember what it's called. Anyway, it was 115, which is low. Not as low as it's going to go, but that's not very high. You'd really want it up around 175 and even 200. But so not a lot to hear on shortwave right now. And I believe the atmosphere is non-reflective, which I've been reading up on a little more. I didn't know this, but at times of high geomagnetic interference, radios can work better because I don't understand this 100%, but because the atmosphere is ruffled up, the reflective part of the atmosphere is ruffled up. For some reason, it'll reflect signals better. Have to think about that for a while. Would it be the case that I often think about this? So looking up at the sky is a little like looking down at some water. So you're standing on the edge of a lake and you look down at the water. What you're seeing is the interface between gas and water. And that interface is reflective because water is reflective or whatever. It's the same thing. You turn it upside down and put it up in the sky. You get the same sort of thing happening. So the question would be, using our radio eyes and looking at the reflective water, are we seeing the same thing, same sort of thing that our radios see in the sky? Radios don't see, I understand that. But so what if the water is perfectly smooth? The water is smooth and you're looking at it and the sun is going down, and when you look into it you see the red ball of the sun. And that's the one spot that is sending light back into your eye. Now if there's all kinds of waves, the water's all choppy, maybe it's windy and boats been going, so it's all choppy. So what do you see when you look out? You see all kinds of little spots, and they're moving around because the waves are moving around, but you see it over a large area. The sun has gone from being a bright dot to being a spread out reflection, I don't know what to call it, a distributed reflection. So is that what's going on when you look up in the sky? You look up in the sky or the radio looks up in the sky, and if it's smooth, then it just sees a point from the transmitter, and maybe that point isn't in the right spot. But when the sky is ruffled up, there's all kinds of reflective spots all over the place, and so some of them are going to reflect down into your location. I don't know. You see, the whole conversation is crackpot because radio waves don't reflect, don't bounce off of things. I shouldn't use the word reflect. They don't bounce off of things. Light does not bounce off of surfaces. There's no bouncing going on. So what is going on is much more complicated than what the models we have. The simple model of the radio wave going up, bing, hitting the sky and coming back down. Well, that's helpful, but that ain't what's happening. It just cannot be what's happening. So, Aaliyah, and I'm not sure what's happening. I'm trying to find out, the deeper story of how radio signals travel around the world, supposedly by reflection. In fact, if you read long enough, if you research long enough, you'll find out that the common knowledge about how a mirror works is not true. A mirror, like a light mirror, like when you see your reflection in a mirror and you think, well, the light is going in and it's just bouncing back. And of course, it comes in at this angle, bounces out at that angle. But light doesn't bounce. It's not a ball. It does not bounce off the surfaces. So as I said, if you look into this, and you have to look a long time because a lot of people will tell you the bounce story. It's in books, it's all over the place. Eventually you'll find some physicist, some paper, somewhere that will tell you what's really happening. and it's hard to believe. I'll leave it at that. You can have some fun finding out what a reflection really is. The reason it's important is understanding reflections helps understand what's going on with these radios and radio waves. And that's part of the hobby, is trying to understand this stuff. I'm all excited about it now. Okay, and bear in mind everything I say could be a pile of bull crap. So use your own head. Okay, enough of that. I'm talking too much. We're going to shut this guy off. And we're going to rejoice. I finally got through the alignment of the broadcast band. It's clearly working quite well. And I've solved a whole bunch of little niggly problems along the way. That's excellent. So what's left now is to do the shortwave alignment. And as I was trying to explain, there's not a lot to hear on shortwave, but we can use instruments to do it. And of course you can only read. Typically, shortwave is stronger in the evening than during the day when I'm in here doing my work. So that's another thing to take into account. Okay, I've talked a lot, and I am done. You see, I kept my door shut so the cat wouldn't come in here. I actually got something done. Fantastic. Thanks a lot for watching, and tomorrow we'll do the shortwave bands, and the radio will be almost finished, because what's next after that is this apparatus here. Great. Have a great day. See ya.